All right, this is the assignment from in class on Monday, December 2nd. So the first 10 problems are kind of just over reviewing all of what we've done so far with triangle congruence. So we have 5 ways to show triangles are congruent: side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. So to show that triangles are congruent, we don't need to show that all 3 pair of sides and all 3 pair of angles are congruent. We can use our shortcuts here. So for side, 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 we can show that 3 pair of sides are congruent. For side, angle, side, we can show 2 pair of sides and then the pair of included angles, meaning the angle between the 2 sides are congruent. So we don't need everything. Okay. So question 1 through 4, it's asking us to tell whether the theorem or postulate can be used to show that triangle LMN is congruent to triangle QMP. So they're giving us 2 pair of congruent sides, and they're also giving us that angle N and angle P are right angles, so we know those are congruent by the right angle theorem. If we go down our list of things to look for, we have vertical angles. We know vertical angles are always congruent, so we can fill that in. And we can also use the third angle theorem. Since we have 2 pair of angles that are congruent, we know the third pair of angles is going to be congruent. That's what our third angle theorem says. If 2 pair of angles are congruent, then the third pair of angles are congruent. Okay, now we can look at and see if these theorems would work. So angle, side, angle, we need 2 pair of angles that are congruent and an included side, meaning a side between the 2 angles. So here we could do angle, side, angle, angle, side, angle. So we have 2 pair of angles that are congruent and the included sides are congruent, so that's a yes. We also have angle, angle, side, so that's a yes. Hypotenuse leg requires 3 things. It requires right triangles. We do have right triangles. It requires 1 pair of legs to be congruent. We have that, but we don't have hypotenuses that are congruent, so we're going to have to say no. Okay, the 2 hypotenuses here are ML and MQ. Since those are not congruent, we can't say the triangles are congruent. And then side, side, side requires 3 pair of congruent sides. We only have 2 pairs, so again, we have to say no. 5 through 10, we were determining if they were congruent or not, and if they were, we needed to use one of our 5 theorems to show that, or postulates to show that the triangles are congruent. So the first one, we have 1 pair of congruent sides. We can use the reflexive property. We have a shared side, so we can use the reflexive property to show that AC is congruent to AC. But that's only 2 pair of sides, so we're not going to have enough information. This one's going to be not possible. Okay, not enough information to determine if the triangles are congruent. Number 6, we have 2 pair of angles and 1 pair of side. So the pair of sides is not between, it's not included, right? If it was included, it would be between the 2 pair of angles, but it's not, so it's going to be angle, angle, side. Angle, angle, side. It's the non-included side, it's not between. If it was here and here, we would have angle, side, angle, but it's not included, so it's angle, angle, side. All right, again, we have a shared side, so we can use the reflexive property. We have 2 pair of congruent angles there, 1 on each side of the side. So we're going to have angle, side, angle. The side is included, meaning it's between the 2 pair of angles. Angle, side, angle. Okay, number 8, we can use the reflexive property. We now have 2 pair of sides and 1 pair of angles, but the angle is not included. It's not between the 2 sides. So we can't use side, angle, side. And the order we have it in would be angle, side, side, but we can't use that theorem, right? We don't have angle, side, side, and we don't have angle, angle, angle. But we can look for hypotenuse leg because we have right triangles, right? The right angles tell us we have right triangles. The other 2 conditions are congruent hypotenuses. So HF is the hypotenuse for both triangles. So that's congruent to itself. And then EH is congruent to FG. Those would be your congruent pair of legs. So we can use hypotenuse leg because we have right triangles with hypotenuses congruent and 1 pair of legs congruent. Number 9, we have vertical. If we keep going out our list, we see this arrow indicating parallel lines. If you have parallel lines, you need to look for alternate interior angles. Okay, so if we draw our transversal, And here's our parallel lines. Okay, these alternate interior angles are congruent. And then we have angle, side, right? Two pair of angles. And we have angle. Okay, we could also do this one as our transversal, and then these would be alternate interior angles, which are congruent because the lines are parallel. And then you could do angle side angle, or get angle side. So it really could be or. Side angle. This one you could also do third angle theorem, and then do angle side. Would work. This one we can use the reflexive property. And then again we have angle side, or we have angle side. Okay, now the two proofs. Scroll down. Okay, so the first one here, we have statements and we have reasons. So we have our given. Our given here is that angle PRS and angle RPQ are right angles. Okay, we also know that SP is congruent to QR. If we go down our list, the first thing we have is shared sides. So we can use the reflexive property. The reflexive property will tell us that PR is congruent to PR. That's the side that's being shared in both triangles. We have right angles. We can use the right angle theorem to say that our right angles are congruent. But if we do that, we would then have angle side, which is not one of our postulates we can use. So because we have right angles, we want to look for a hypotenuse leg. Okay, SP and QR would be our hypotenuses. They're congruent. PR and PR would be our legs, one pair of the congruent legs. So we can use HL. But first we need to say that they're right triangles and then use HL. Because the three conditions for a hypotenuse leg are congruent hypotenuses, one pair of congruent legs, and they're right triangles. So we need them to be right triangles. Because they're right angles, they're right triangles. So for step 3, we can say triangle PRS and triangle RPQ are right triangles. Okay, and that is because of the definition of a right triangle. Right triangle is a triangle that has a right angle. So since we have right angles and they're triangles, we have a right triangle. 4, we now have all three conditions. We have a hypotenuse that's congruent, we have a pair of legs that congruent, and we have right triangles. So we can say that triangle PR, right? We can say that triangle PRS is congruent to triangle RPQ by the hypotenuse leg theorem or postulate, depending on which really ultimately an exercise of semantics. Let's go to the next one. So we have our statements and our reasons. First step of any proof is always the given. So we start with our given. Okay, there's 3 pieces of information here. We have BD is congruent to FD. We have D is the midpoint of CE. And we have angle BCD and angle FED are right angles. Okay. So 3 pieces of information that are given. If we go down our list, we don't have vertical angles. We don't have shared sides. We do have a midpoint though. Okay, so if we have a midpoint, we know D is in the middle of CE, so it cuts it in half. So CD and DE are going to be congruent. So CD is congruent to DE. That's the definition of a midpoint. Splits it into two congruent segments, two equal pieces. So we can fill that in. Right, so now we have hypotenuse is congruent, that was given. We have our two pieces there that are congruent. Okay, by the definition of midpoint, that's our pair of legs. So we have our hypotenuse. We have our pair of legs. The last thing we need is right triangles. We know they're right triangles because they're right angles. So because we have right angles, we know that triangle BCD and triangle FED are right triangles. That's your definition of a right triangle. Right triangle is a triangle that has a right angle. So since it's a triangle and it's got a right angle, it's a right triangle. Okay, now that we have all three conditions met, we have right triangles, we have hypotenuses congruent, and we have one pair of legs congruent. We can say the triangles are congruent. So triangle BCD is congruent to triangle FED using hypotenuse leg. And that's that for that one.